Welcome to the Agronomy and Farm Management Podcast. I'm Amanda.
And I'm Elizabeth. Thanks for joining us today.
Welcome back to the Agronomy and Farm Management Podcast. So we've had another wet start to spring here in Ohio, but despite those wet conditions, we have had some days to get into the field, and we've got both corn and beans planted around the state. And now it's warmed up and some of that corn is emerging, and we start worrying about the risk of flooding in fields, especially if some of these wet conditions continue. So if you have young corn that spends some time underwater, making the decision of whether or not to replant can be difficult. And with us today, we have Dr. Alex Lindsey from the Department of Horticulture and Crop Sciences here at Ohio State University. And he's conducted some research on how flooding affects corn yields, and then also how nitrogen management can affect the severity of that damage. And he's going to share some of that with us today. Welcome, Alex.
Yeah, thanks for having me. My first time on the podcast, but I'm a long-time listener.
That's great. So really there's two ways that corn can be affected by flooding, and that's physiological damage and then nitrogen loss, which is one that we really are concerned about because it's something we may or may not be able to control. We're also putting money on that field when we put nitrogen on there. So I think it's really interesting, this study that you guys have been doing to help us make some of those decisions economically. So why don't you start off by telling us kind of what the structure of the study was, the different treatments that you had in there?
Sure, yeah. As we know, there's kind of two things going on when we have waterlogged conditions. So there's not only the nutrient balance within the system, but there's also the plant physiological responses. So when plants get flooded or are experiencing waterlogged conditions, a few different things happen. So in short-term situations, basically the plants will start to just kind of slow down their physiological processes. But then after about 2 days, the plants start to realize this isn't necessarily a temporary situation, and they'll start to put more effort towards root production. They'll change a little bit how the roots are structured and start to explore their soil environment a little bit more, trying to find pockets of air and nutrients that are available to them. And so in that time, they'll kind of reduce their shoot growth as well to reflect that shift. And so not only are the plants responding in that way, but they're also experiencing some level of damage. So they shut down photosynthesis a little bit. They close their gas exchange sites called stomates. And basically that causes a buildup of light energy in the leaves. They can't regulate temperature as much, and so some damage starts to occur at the leaf level. But the duration of the flood can also impact these physiological responses. So the longer a plant's under flood conditions, the harder it is for it to recover after the flooding recedes. But the other aspect is the nitrogen. We've heard a lot about nitrogen loss from environmental conditions when we have waterlogged situations. Water can either volatilize off the soil surface if it's moist but not waterlogged. The more likely culprit is denitrification or leaching. Basically the movement or conversion of nitrate into other gaseous forms that aren't plant available, that are lost to the atmosphere, or the loss of nitrate out of the root zone. And so our study was kind of looking at the interaction of these two different responses. So what happens to the plants and also what happens to the nitrogen in the system. So we designed it with 3 different nitrogen treatments. We had either no nitrogen applied, 120 pounds of nitrogen applied pre-plant incorporated, or a third treatment that received 120 pounds of nitrogen pre-plant plus an additional 60 pounds applied side dress around V4 to V5 growth stage. We'd stacked that with 4 different flood treatments, either a non-flooded control or waterlogged conditions where the plants were inundated with water for 2 days, 4 days time, or 6 days time. And basically after the flood ended, we came in a week later and applied our side dress treatments.
So how did you actually go about flooding the field? Just the mechanism of that?
Yeah, so that was kind of a challenge. We ended up doing this research at the Waterman Research Farm in Columbus and also the Western Agricultural Research Station in South Charleston, Ohio, because we had the ability to apply irrigation. So basically we used groundwater wells and applied drip irrigation at a high volume for 24 hours a day to these plots. So basically water was constantly flooding these plots. And to keep the water in place, we actually made a little soil berm around the large plots area. Basically, it was a berm that was about 4 to 6 inches high next to a trough. And basically, that helped keep the water in place. Each one of those drip lines had a valve on it. And so when our termination time happened, so basically 2 days were over, we were able to turn off each individual line, and those plots ended up finishing infiltrating and started to dry out. And so that's how we implemented the flood each time.
What about rain during while you were trying to get the dry out period so you can make the application? What happened with the weather in those 7 days, and do you feel like that had any effect on the results?
Sure, yeah. The weather around the time of flooding was pretty consistent, even though we did it at different sites and in 2 different years. So we had one site in 2017 and 2 sites in 2018. But on average, our daily highs, the max temperature was somewhere between 81 and 86 degrees Fahrenheit. And we had pretty consistent weather events where we got maybe 1/10 to 2/10 of rain every 2 to 3 days. And so when we were actually doing our top dress, side dress application, we had weather events that actually helped to incorporate the nitrogen. So I think this was kind of best case scenario. The field was dry enough to make the application, and we got timely rains to actually incorporate that top dressed urea. So I think this in some ways might represent kind of a best case scenario recovery application if using top dressed urea.
Yeah, that's a good point, because I know there are soils around Ohio that have really bad crusting issues where if it just dries out and you don't get any rain, then you're going to have some problems. Of course, that's more related to, I think, before the corn's emerged, but having that rain a little bit probably helps soil conditions as well.
Right, and if your plants end up getting flooded to the point where complete submergence, sometimes you can get soil to build up on the leaf tissue. Mm-hmm. And so just a little bit of gentle rain, ironically enough, can help those plants get rid of some of that soil on a leaf tissue and help get those plants back in working order.
So what sorts of yield impacts did you see to the flooding at the different stages?
Sure. What we saw, regardless of year and site, was a pretty strong interaction between nitrogen and flooding. And basically, when we had 2 days of flooding or fewer, basically our 0 and 2 days, when we had a full nitrogen rate treatment, yield wasn't really impacted. So after 2 days, the corn was not damaged to the point of yield loss, and that additional nitrogen really helped to increase the yield.
Sorry, I'm going to interrupt here for a second. In the ones that were only flooded for 2 days, did you still make a side dress application after that?
So in the ones that were flooded for 2 days, we had our 0N treatment. We had 120 pounds applied pre-plant and the side dress. Yeah.
Okay.
Yep. And so when we only applied pre-plant nitrogen, we did see yield was negatively impacted, but it was not to the point where it couldn't be overcome with a supplemental nitrogen application or a rescue N treatment. Our 4-day flooding, we saw pretty deleterious issues. Basically, yield was really hurt when no side dress was applied. But as soon as we applied that side dress, we saw a substantial yield increase, but we still saw max yields that were about 15% less than what we saw in our non-flooded full nitrogen treatment. When we got to 6 days, basically that yield hit was down to 30%, or about 33% of our full fertilized non-flooded control.
A third that's quite a bit of yield loss to think about just with less, about a week of flooding.
Yeah, that's interesting. So at this point, then you can start to use those figures to make some economic decisions. Have you looked at any of that? Like if your yield was reduced by a third, is it better? What do you do at that point? What's the best method for that field?
Sure. So that's a really good question. And I think that's kind of where the next steps for this research are going to come from. So we quantified leaf tissue nitrogen at R1 stage, which is when you should assess corn for sufficiency levels of nitrogen. And basically we saw that anytime we had flooding for longer than 4 days and a nitrogen rate less than 200 pounds, 180 pounds of nitrogen applied per hectare in total, basically our sufficiency level was less than what it needed to be. And so that makes me wonder if in our 6-day flood treatment we applied enough nitrogen to get back to sufficiency, or if the plants were just damaged to the point where they couldn't actually take that nitrogen out. So we generated some really good preliminary data, but we need to take it kind of that next step to see at what point can we get our yields back up to with additional nitrogen application. Again, our side dress treatment in this study was only 60 pounds of nitrogen, which may have been less than sufficient to get it back to maximum yield in those 6-day flood treatments. But at the same time, you want to balance that with costs of nitrogen that were applied up front, as well as potential loss from yield. And so those are kind of the next steps. We can't really say for certainty based on the results of this study, but in our assessment, regardless of flood duration, yield and return to nitrogen was increased with a side dress application, even at 6 days worth of flooding.
Okay.
So it seemed like doing some sort of rescue and treatment was appropriate from an economic standpoint, but as far as the actual rate and targeting a specific rate, we can't really say that from this study.
So the next step might be looking at, you're thinking perhaps from the 6 days of flooding, you lost a significantly more or larger amount of nitrogen from that pre-application that you need to make up for. But then how does the economics come into play?
Right. We saw that with the 4-day flood too.
Okay.
So basically the 4-day and the 6-day flood seemed like they lost pretty much all of the nitrogen that was applied pre-plant.
Okay.
And we were able to get to basically the sufficiency level with our 4-day flood with 60 pounds of N, but we may not have gotten there with the 6-day. But like I said, that's kind of future research. The other thing is looking at different N sources, particularly used pre-plant, to see if different nitrogen stabilizers or nitrogen products may be able to retain nitrogen longer even in the event of a flood compared to non-treated incorporated urea, which is what we used in this study.
Yeah, I think this is really interesting given the last few years how we've seen increased localized flooding events in those higher risk areas. So maybe farmers can start thinking about, in this field, I've had, fairly frequently flooding, delaying my nitrogen application. Of course, that's easier said than done depending on what your equipment is, but putting more on afterwards. And we've had several studies, late season nitrogen application, that's shown as long as we're able to get in there with the nitrogen, it can be as effective as putting it on at any point in the growing season.
Yeah, the most rapid time for corn nitrogen uptake is between that V6 and VT growth stage. So corn needs roughly 30 pounds of nitrogen before that V6 growth stage. So if it's been easier in the past to apply nitrogen pre-plant and then go in and plant, if you're seeing more and more frequency of nitrogen being lost potentially due to flooding situations, it may be worth it to reassess the management practices in those areas to potentially do more later in the season rather than putting the nitrogen budget on up front.
Yeah. What sort of relationship is there between the growth stage that the corn is at and its ability to handle being submerged?
That's a good question, and corn tends to be more susceptible early in its life stage and also during pollination. Those are kind of the two critical times when moisture stress impacts growth and development. Corn is most susceptible to flooding kind of in the early vegetative stages, and it seems to be tied in some ways potentially to soil nitrogen levels. After about the V10 growth stage, corn becomes a lot more resilient to withstanding longer periods of flooding. It's also less likely you'll have entire submergence of the entire plant. Many of the lower leaves at V10 are going to be smaller contributors to the photosynthetic budget of the plant, meaning they're not being used as much to produce photosynthesis. So if you end up having those covered in mud, they're not going to necessarily impact yield and growth as much. During the reproductive stages, corn is pretty tolerant to flooding conditions. Pollination is kind of a critical time, but during the grain fill period, the plants are usually, they have a large root system where they can withstand a lot of that.
Yeah, I think it's always interesting to see in some of these fields how this time of year a 2-inch rain can leave standing water, where if we get a 2-inch rain in July, the corn sucks it up almost as fast as it can fall.
That's
Right.
a good point.
Depending on the severity of the storms, you may be more at risk to other stressors in corn during grain fill, such as even late season lodging events or potentially green snap events during the mid-vegetative stages. But damage from flooding and waterlogged conditions, I think, is a little bit less the older the corn gets.
So I don't want to go in and make a side dress application if the corn's going to die. So why don't we talk about how we can look at the corn and evaluate it prior to that to determine if it's going to survive?
Sure. So some of the things you can do when looking at a corn field to see if the damage was so severe that it's going to be permanent and the plants aren't going to make it, you can do some simple root digs and assess the root tissue. If it's looking kind of brown, reddish, or black, there's probably been some pretty severe root damage. If the root tissue looks white, it's probably going to be okay. The other thing to look at is above ground tissue. If the leaves are going to turn yellow when you're under water. When you have waterlogged conditions, leaves are going to turn yellow, but the big thing is the growing point intact? So if it's before the V6, V7 growth stage, you can always dig up those plants and split the stalks to look at the growth point. Basically around the nodal roots is where you'll see kind of that meristematic tissue, and if it looks like it's dark brown, those plants may be in trouble. But if it looks to be intact, then those plants are likely to grow out of the condition. Later in the season, you can always pull on the plant whorl, and basically if the plant upper leaves come out of the bottom leaves, then the growing point has likely been affected and may be dying. And so those would be things to look at. Typically, you'll also start to see red interveinal stress in addition to the leaf yellowing.
And that growing point when you split the plant open should be like a white, creamy color.
Yeah, it should be. It should look fairly normal. Yeah, which would
just
be,
in case people haven't looked at it
Right.
before. That's what it should look like. Well, that's certainly interesting and definitely relevant to the weather conditions that we've been seeing here. And you're doing a lot of interesting work across the board. Some of the other things you're looking at are hail damage effects and even looking at lodging, I think you said. So why don't you talk about what you're finding in those studies?
Sure. Yeah, so with more water comes more stress. And in some cases, it's not just the water, it's the other things that go along with the storms that bring us the water. So if we have a 2-inch rain event, it's likely coming in the form of a large storm, potentially that could have hail coming with it, and strong winds. So we're kind of looking at a multi-pronged approach to the environmental stress aspects, and so we're actually doing a mid to late season lodging study where we're actually pushing corn over to simulate wind damage or wind lodging. So the root ball basically pops out of the ground, and then the stalk bends almost to look like a J to recover, and what impact that has on pollination, yield, and recovery. And so we're doing that study. We've got 1 year's worth of data collected, and yields were impacted anywhere from 10 to 60% depending on the stage. So the most susceptible stage was during pollination. So VTR1, when lodging occurred then, we incurred the most yield reduction, partially due to poor kernel set, but also due to basically yield impacts. We had the lower values, that 10%, 15% yield loss, when we lodged about V10, so kind of mid-vegetative stage. The other study we're looking at is defoliation events and how that impacts yield. And so looking at changing up how the recommendations are made for predicted yield loss from 1 to 2, sometimes even 3 hail events in one season. It can happen. We don't want it to happen, but it can happen. And so just making sure that the recommendations for predicted yield loss are still accurate. So those are some of the other projects we've got. going on.
So on the lodging study, what are your treatments there? Is it different types of hybrids or just different types of growth stages?
Sure. So we've got 3 different hybrids we're looking at for that study, and we got 4 different growth stages we're looking at. So V10, V14, pollination, and R3, so early milk. So we're also looking at kind of a late season lodging event and what happens to yield that way. And the 3 hybrids we've got are ranging from 111 day to 113 days, so kind of a full season hybrid for assessment. And basically we've irrigated the field to the point where we have 1.5 inches of water applied, so much that the soil is really wet. Then we take 2x4s at the base of the plant and just push the plants over.
I was wondering how you did that.
And then we rate recovery. We rate light interception differences between the treatments to see how that might impact yield. Measure yield, and also issues with ear pollination, ear fill, and also premature germination. So at R3, if the plants are touching the ground, we get a wet fall, those kernels might end up germinating, resulting in lower marketability. So lower yield, potentially lower marketability, and quantifying those aspects.
That sounds like a horrible trial to have to try to harvest in the fall.
We harvest that one by hand
Okay.
for our yield estimation, but then the branch managers have been really good at cleaning up those fields for us afterward.
Yeah, a field of lodged corn, it doesn't get much worse than that.
Yeah, it's not fun to walk through.
I bet.
That's for sure.
So are you anticipating any changes to the defoliation recommendations based off of what you're seeing so far?
So the biggest changes we're seeing are in the multi-defoliation predictions. So sometimes the predicted charts are a little bit high on yield loss, sometimes they're a little bit low, depending. Corn is a really interesting crop in that when you lose leaf matter, sometimes the leaves respond better because there's not as much of a respiratory draw, and the leaf area changes so that it can photosynthesize a little bit differently. So it might change the optimum a little bit, so the yield penalty may not be as much as you might expect. Other times, it's just as detrimental as ever, or worse. So that's kind of what we're seeing. So we're kind of updating those as they come.
Yeah, so how do you simulate the defoliation?
So what we've been doing in very early season, potentially using something like a weed whip, something to go out and clear cut the plants right at the base for very early season defoliation events. But most of the time it has to do with scissors or shears defoliating.
So
that
very
way.
labor intensive.
These are smaller plots.
Yeah.
Again, all harvested by hand. But yeah, it's kind of how we've been doing those trials.
I always think it's interesting to hear about just the ways that you simulate different effects in the field, and
Yeah.
you gotta get kind of creative sometimes.
Abiotic stress is a whole different ball game, and when you're trying to manipulate the weather, sometimes it works well, sometimes it doesn't. But we try. We do the best we can to try to simulate these real life scenarios.
Yeah.
Yeah, and we appreciate that because, as you said, they're real life, and we do see this in the field. So any resources you want to share with our listeners that they can find out more information about your work?
So just keep your eyes tuned and to the Core newsletter. We'll have some articles coming out. Potentially we'll be developing some journal articles that might end up turning into fact sheets as well from some of this research. And hopefully we'll be able to continue it on to get more concrete recommendations as far as rates and potentially different products for the future.
And you're usually at a couple field days throughout the summer, so people can come out and talk to you there as well.
Yep, you can also reach me through my email. If I'm in my office, I answer the phone. So if you call me there too, I should be around.
Awesome.
Well, Alex, thank you so much for joining us today.
Yeah, thanks for having me. It's been great talking with you today, and I hope I helped answer some of your questions.
All right, and let's just hope the weather stays nice and we get planting completed and a great start to the season.
And speaking of weather, we're going to wrap up with a quick weather update from Aaron Wilson. So here he is with that.
Hi folks, this is Aaron Wilson, Climate Specialist with OSU Extension Ag and Natural Resources Group, bringing you the weather update for May 2019. Certainly over the last 30 days, it has been very wet across the state. Many of us have picked up at least 5 inches of rainfall for the month of April, with some locations, some counties, Darke County, Auglaize, Mercer, Allen counties, and even Highland and Ross, some of these areas picking up 8 to 10 inches of rainfall over the last 30 days. This is certainly well above average. Some places seeing more than 300% above average for the last 30 days. This is making planting season very tough, and certainly we want to know as we head into May what the weather outlook is looking like. Particularly, we're dealing with very saturated soils out there. Much of the state is in that greater than 99th percentile. Essentially, we're talking about the top 1% of wettest soils that we've had on record for many parts of Ohio this planting season. So what's going to happen as we turn the page now into May, looking forward in time? Looking at the latest outlooks from the Climate Prediction Center, first the 6 to 10 day outlook. This is the May 5th through May 9th period. We're looking at elevated probabilities of warmer than average conditions across all of the state of Ohio. And with that comes an elevated probability of wet conditions sticking around or above average in terms of precipitation for the 6 to 10 day outlook. It's about the same stories. We look 8 to 14 day outlook. This is the May 7th through May 13th timeframe. Again, most of the state in that elevated probability of warmer than average conditions, with elevated probabilities of wetter than average conditions for the 8 to 14 day period. Again, that's May 7th through the 13th. We don't have an update just yet on the May outlook. The previous outlook called for equal chances of above, below, or near average precipitation over the month of May. But if the first 2 weeks outlooks are any indication, it looks like this is going to be hedged more toward wetter than average conditions across Ohio for the month of May. Again, with warmer than average temperatures expected as well. Expanding that out a little bit further, still we're looking May, June, and July now. We're looking at, again, above average temperatures, likely, at least an elevated probability of above average temperatures for that May through July period, with elevated probabilities of enhanced or greater than average precipitation across much of the state. So unfortunately, it looks like from a climate perspective and an outlook perspective, a little bit wetter than average and warmer than average, but hopefully there'll be some windows of opportunity to get planting in over the next 30 days. Until next time, thank you for listening to this weather update. We'll talk to you soon. Bye-bye.
Thanks for listening to the Agronomy and Farm Management Podcast. Join us again in 2 weeks for our next episode.